Thank you for joining us on this Tuesday evening. Nice to have some of you in already. I see we've got the regulars in. We've got Gerard. Hi, Gerard. Thank you again for your generosity. We've got Kevin. Who else is here? If you're here, just say hi in the chat. Like to know who we're talking to, because allegedly people do watch us occasionally, so we'd like to know who they are. And anyway. So anyway, here we are on a Tuesday evening. So it's going a bit mad today. Hope you've all had a fantastic week. I'd like to welcome our regulars to Space Oddities. I'd also like to welcome Mr. Brian Jones, who's you may be familiar with Brian. You've probably seen him on here a few times. But it's nice to have you back, Brian. Everything okay?
I think so, yeah.
Great. And we welcome back Ian as well from last week. How are you, Ian? How are things going? You're on mute.
Great, thank you.
Fantastic.
Yeah.
Oh, we've got a low frequency buzz on the sound. It could be coming from Ian.
Yeah, you probably coming from Aaron.
Ian, can you just mute yourself for a moment?
I just did, so not me.
Oh, it's not you. Oh, okay.
Yeah.
And we'd also like to welcome Aaron, who was here a second ago, but he's disappeared.
And I will be back. Can you hear me?
Yes, we can hear you.
Okay, so hello all. Good to be with you, at least partially again.
Good. Nice to have you back. We had Aaron briefly in vision a little while ago. Let's hope that he does indeed come back. But we've got Michael, of course. We've got Roger. We've got Daz. Daz has just recovered from a rather nasty bout of illness.
Yeah, I'm over me melodies. So
yeah,
me melodies. I mean, not melodies. I wasn't singing.
Your melodies.
My melodies.
You still look terrible though. So
I just burnt off a few more million brain cells. So
you can't have many left, mate. You didn't start with me. No. So there we are. Anyway, what have we got for you tonight? Well, tonight, a bit later on, we're going to be discussing the rather interesting idea that Elon Musk has put forward, that he says that SpaceX are going to build a city on Mars for 1 million people by the year 2050. Now, I think you'd agree with everybody, that's just crazy. However, I thought what we'd do this evening is to discuss the actual issues of establishing some sort of human outpost on Mars and when it's likely to happen. So we hope you'll join in that conversation. If you have any views on that, which I'm sure you have, put them in the chat. We'll get to that a little later. Just the usual sort of housekeeping stuff. Don't forget we have the Space Oddities merchandise available, which is at the Space Oddities shop. Now you can scan the QR code. Apologies that there's no link to that you can click on that's popped up in the chat. This is an ongoing bug I'm trying to sort out with our software producer. They haven't managed to fix it yet. It's been going on for a couple of months now, but we are optimistic that they will sort it soon. You can buy T-shirts, you can buy hoodies, and hopefully we're going to be expanding the line of merchandise even more. And for the T-shirts, we are asking the entirely reasonable sum of £25 plus UK, including UK postage and packing. For the hoodies, they are £40, including, again, UK postage and packing. If you're outside the UK, please add £10 to the total value of your order to cover the postage. And there you are. And, you know, we've all got these T-shirts. And Daz, you've got a hoodie, haven't you, Daz?
yeah, I'm wearing one of the retro ones. I don't know if you can see that. One of the retro ones tonight. But
Right.
so, yeah, I've got them all. I've got the full set.
Oh, I've got a hoodie as well.
Yeah.
Yeah.
So we do actually wear this stuff, and we wouldn't offer it to you unless we thought it was good quality stuff.
Oh, I wear mine dancing.
Do you really?
Yeah.
Right.
You're going out gear.
Right.
Me
Okay.
pulling gear.
I think
it gets
probably better to
worse.
fail over that as soon as we possibly can. Moving on. Happy Halloween for tomorrow, by the way, everybody. Hope you have a good one. Doing something crazy for Halloween. And there we are. So what I think we'll do first this evening is to say, if you've got any questions, anything you want to say, don't forget to put it in the chat. If you're new here to Space Oddities, you are incredibly welcome. Lovely to see you. And if you are new here, why not introduce yourself in the chat? Tell us who you are and maybe a little bit about yourself. But we'll move on. And the first thing we're going to go to tonight is the news. Let me just set this up and we will have a look. Not many notable items in the news this week, but we have got some interesting stuff to look at. And I don't appear to have that available. Just give me 1 second, please. And
Hi, Aaron. He's fallen over.
We've driven that up the wall.
We have a problem. Hey,
That's better.
Yeah.
there we are. There's Aaron, seen for the first time Space Oddities in ages. So this is interesting. I had to completely reinstall Windows on my PC this week, and now I don't appear to have the correct window available to show you the news. So we'll come back to that later because we'll try something else. We'll come back to the news later. Apologies for that, but this is what happens when you go through that incredibly traumatic experience of reinstalling Windows, as I'm sure you know. So Roger, can we come to you first this evening?
Absolutely, you can.
Thank you very much. Let's get this the old steam kettle on, and here we are.
Okay, so we do have a previous gallery that we missed from a couple of weeks ago. So that's to be added on to with what else we've had earlier. So let's get on before we get to that with the usual items of what's in the night sky. So we go through from the 29th of October to the 4th of November. So we go through Halloween and almost up to bonfire night. So we're in the last phases up through to the new moon, which goes over through into the weekend, and then onwards through to its next course of phasing. So this was just a couple of nights ago where we had the moon at 31%, which was quite a nice sight to see. And later on that day, I managed to get to see the sun for a week or two. So here we got white light calcium in the middle, and then some H alpha of some of the activities that we have actually been getting again through this past week or so, even though there aren't an awful lot of spots, but what there is certainly getting quite active. So we'll hear more about that hopefully later on with Daz. Okay, so we're coming through, and now as we've got the clocks back, we're getting quite dark skies now by 6 o'clock. So I've got this still for midnight. So obviously with the clocks going back, everything is now further up in the night sky, where we are starting to see Orion coming up through. Although we do still have Saturn setting over towards the west. We've got Uranus and Jupiter in Taurus, and we've got Mars coming up through between Gemini and Cancer. So still quite a few planets to look at through the night. And there we go. So as we get through to the week, all looks great. So just before sunset through this week, we've got Mercury just above the horizon, although it is still quite low. Should you be able to see it, there is a possibility of some viewing of that little planet. And we've also got Venus, which will be coming higher and higher into the evening sky, and will look quite nice and bright out towards December time. So keep an eye out for that event. Okay, so we've still got Comet A3 Shinshun Atlas coming through Ophiuchus, although it will be then going through Aquila, heading over towards that way. But as we can see, it's now getting beyond normal visual observation with the naked eye, starting at about 5.9 and then fading fairly rapidly over the next month to about magnitude 8.5. So anyone having a chance still to see it, it will obviously be more likely to be seen with a camera rather than any visual aids if your skies aren't particularly clear. Okay, so here we go for our bumper gallery from a few weeks ago, and
Whoa.
that's some images that I took when I was at Stonehenge. There was only 3 of us from a camera club there through that night, and we managed to get some quite spectacular illumination, even though it was cloudy on occasions, where the thin clouds were still able to show the striking red, vibrant colours that we did actually be able to see with the naked eye without any help at all, and it was
That's
quite
intense.
spectacular. Yeah, and this was one of my pictures of the comet, although this was only a few nights ago, and it was just taken with my little mirrorless DSLR, so I was quite pleased with that. Although I haven't got the anti-tail on there, unfortunately, but it's one of my better images of a closer up view of the comet. Right, so Ian McIntyre, I think we did see a previous version of this in last week's, where he was trying to take a picture of the moon with his phone, and getting an interesting view there. Graham has got a sea star picture, which was just a cropped picture straight from his sea star.
Wow.
Came out rather well.
Yeah.
We've even got some mineral color there, I believe, as well, by what I can see.
Yeah,
a little bit.
it's like blue,
Done
it's
quite
like
that
brown.
well.
Mm.
Yep, done well there. Well done. And Jerry's got his Iris Nebula on his usual get-up, and he's
Ooh,
got
look at that.
fantastic,
Wow.
some fantastic detail of the surrounding gas from that star. So well
That's
done,
beautiful.
Jerry. Very
The spikes
nice.
make all the difference, don't they?
Yeah, that color is quite spectacular.
Wow.
That electric blue.
Well done,
Yeah.
Jerry.
Also looks effective with the refraction spikes as well.
Yeah, well, it's from his Richie Critty on. So Sonia's managed to
that's right.
take some quite a few pictures of the Aurora over,
Ooh,
and she
Wow.
did get some quite stunning images of the curtains that became available. As you can see, you've got the greens and the blues and the purple there, and the reds. And obviously, a lot of people seem to find that the redder colours were much more prominent than when we had them in on the 10th of May. So
That's a nice
obviously,
colour, this.
so you got some almost overhead there as well. So we've done very well. Right, so we're back to Graham again for the M33 in Triangulum, and just a little bit of processing on his iPad, and
That's nice.
managed to get some of the spirally arms on that as well. So well done. Very good. Okay, and then he's managed to get some of the Aurora as well, which was on his Android phone night vision setting.
Gorgeous.
Oh, nice.
Ooh, nice bit of red glow going up there.
Very moody.
Very good. Well done. Right, and Michael, he's posted another one of his solar images with his Skywatcher and his on a solar quest, and this is what he's managed to get.
Lovely.
Some very chunky, lumpy sunspots there, which we haven't seen for a little while, but yeah, very nice.
Some
Well done.
chunky things.
Very, very huge. Right, so we got Gerard with a waxing crescent moon from the Larkhill Observatory. Got some interesting crater detail there near the Terminator.
That's nice, yeah.
Very good. Well done. And one from Lee. We haven't heard from Lee for a while, so he's put this picture of the comet in over Delabole in Cornwall with his Canon and his 50mm lens. So it's a stacked and processed image where he's got the foreground and separate from the night sky, and then just compose them so you can get a better image.
Oh wow,
Oh, that's lovely.
Look at that.
that's amazing.
And yeah, he did put a comment in to say that the thin clouds giving some of the bright stars a bit of a glow, which gives it a bit more atmosphere.
Yeah, giving them a halo, isn't it? Sort of a halo effect. Lovely.
Yeah,
Beautiful.
very nice.
Well done, Lee. That's amazing image.
Lovely.
Great.
Well done, Lee. Very good. So we've got joint effort here from Kay and Keith Pearson, who was out enjoying the views of the May Aurora, and we've got quite a few pictures here that they were taken, and it looks like they had quite a fun time capturing all these pictures around the house and around the area where they were. We've got some outside around the house, and we've got some.
Oh, look at that!
Around.
Wow, look at that.
Right over.
Yeah.
Yeah, very strong.
Was it? Did you say this is the May the 10th?
This is from the May edition.
Yeah,
yes.
May event. Yeah, May the 10th.
Yeah.
That's lovely.
And see over by the church as well. So quite an amazing presentation.
You can understand why some people think, or in the past used to think these were angels in the sky. Just look at the shapes and things like that. It's absolutely fantastic.
Yeah,
It's lovely.
Great.
yeah.
Right, and we've got some solar imaging from Pete here.
Who?
Yeah. Somebody.
Somebody.
Shut up.
And we've got some
Look at those.
concepts of the.
That's like a drawing, isn't it?
Yes, it really does look. I think they call these when they're sort of like these wifty lines of. They call them hedge prominences. They look like a hedge on the side.
Oh,
so,
yeah.
Yeah, it almost doesn't look real.
That's
yeah,
right.
it looks
doesn't.
lovely, doesn't it?
It's probably not.
Yeah.
Whoa, look at that. And you've got the sunspots actually on the sun as well, which is the texture on that is absolutely gorgeous.
Well done,
Well,
Pete. That's amazing.
Well, he does know how to process these.
It's lovely,
Yeah.
isn't it?
Well, if he doesn't know by now,
You never will.
nope. So, there's been some quite spectacular images coming away from there as well. So, Juno image here of a recent past that it did, and some of his processing of that.
Oh, wow.
So that was on Pete's phone, was it?
Yeah, that was on Pete's phones.
Yeah, just out the back door.
Yeah,
Yeah.
That's cool. That's cool,
It's-
isn't it?
on the
It still amazes me that we're so used to images of Jupiter just showing the cloud bands and the red spot. But when Juno got close up to it, it turned into a completely different, almost recognizable planet. It's amazing.
yeah, absolutely spectacular.
Yeah, personally, I think it
And,
looks like a Peter Max drawing.
Yeah, but we didn't.
Right.
We didn't see that sort of detail from Galileo, did we?
No, not at all. Of course, what you're looking at there is the South Pole.
Yeah, yeah.
And the fact that the camera on Juno, was that a lot better quality than the one on Galileo?
Yeah.
Possibly, yeah, possibly. But I just did notice in the chat that
But
was getting lots of hearts. People like that.
Nice.
That's-
Yeah, that's beautiful.
Because the camera on Juno was a secondary one, wasn't it?
Yeah. Well, it was an afterthought, wasn't it? They weren't going to put a camera on
thinking.
Juno originally.
No.
The Galileo was had a design camera.
Yeah, I wonder why that is.
Yeah.
There we are.
Right.
Somebody's got that for homework.
Here we
Let's find out.
Yeah.
Okay.
And another one from Pete's back garden with a 2-meter telescope.
Yeah.
If you look at this, 2 seconds of red, 2 seconds of green, 2 seconds of blue, and this is what you get.
Whoa!
Oh.
That's what, this is what happens when you've got a light bucket.
Yeah.
Or even a heavy one.
Yeah.
Oh.
Dear, oh dear.
Sorry. It's going to be one of those nights.
Well done, Pete.
That's good talking for
Uh,
sorry.
Yeah.
And just to finish it off, one of my pictures of the Ring Nebula, and this is only an hour of red, green, and blue each. So that's 4 hours altogether, and this is what we got.
Wow.
Lovely.
See, Pete does his in 6 seconds. I do mine in 4 hours. That's the difference in aperture.
Story of your life, mate.
Yes.
Very nice. Very nice.
Is that the dumbbell, Roger?
Yeah. That's the dumbbell.
Yeah.
M27.
Lovely.
Okay, so managed to finally get through all these pictures of the backlogs and what we keep getting come through. So keep coming them through.
Absolutely, absolutely. Now, I would just like to thank you all for sending in your images, and do keep them coming in, because as you can see, we just absolutely love them. We love to watch them, look at them. So how do you do it? You basically attach an image to an email, 1 image per email, please. Address it to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. Put the word gallery somewhere in the subject of the email so that it'll be picked up automatically and put in the requisite place for Roger to sort out. And there we are. And, you know, we're not just after deep sky objects or solar images. We like seeing any images of the night sky, skyscape or anything else. And, you know, whatever equipment you take these images with, it doesn't have to be expensive. You know, mobile phones are giving brilliant results these days. So, you know, it doesn't matter what the equipment is or how much it costs. If you've got an image you'd like to share with us, that you like to see in the gallery, and have everybody go, ooh, then please send it in to us. And,
it doesn't have to be contemporary either. Just anything from the past, something that you've seen from, you know, in years gone by that you think, oh, that was my favourite. Put it in. You know, we like to see everything.
Yeah, absolutely.
So,
right. Well, we'll move on. And I'm going to give the news another try now, because hopefully I've sorted this. So just give me 1 second. And there we are. That's
while you're doing that, Andy, Sandra's asked a question. She said, I wonder how noisy it is on Jupiter with all those storms.
Well,
Very.
Yeah. We know, obviously, that Jupiter has a lot of lightning. And, you know, this is fairly major league lightning. The lightning bolts on Jupiter explode with the force of a nuclear bomb. So it's a very violent atmosphere. And if you're within the atmosphere where presumably sound would travel, having a medium to travel through, it would probably be exceptionally noisy, Sandra. Yeah, I can see that happening. Not that we'll ever know personally, of course. But there we are. Okay.
You probably melted before you get a chance to...
Yes. Anne says, evening all, sorry we're late. Don't do it again, Anne. Told you this before. If you're going to come and watch us, turn up on time. You know, just outrageous behaviour. Anyway, nice to see you, Anne and Mick. I hope you're both well. Hope to come and see you soon. So anyway, the news, ladies and gentlemen. Let's hope this works. Okay, so just a few items in the news tonight. The first item is about black holes, which is why I've got the black hole background behind me. Let me ask the panel a question. How many different ways do you know of to make a black hole?
Oh.
Combination of 2 stars.
About three.
They're massive.
I would go with 3.
Right, so there are a few ways. Obviously, a supernova explosion, yes, which is probably the most common, in fact, where a massive star explodes and then the core collapses into either a neutron star or black hole, depending on the mass of the star. What about supermassive black holes? What do you know about their formation?
Well, they could be collision, mergers of black holes.
Yeah.
And possibly just if you've got enough gas, it could be just a collapse of gas into a black hole.
Absolutely true. Any other ways?
But as they say, if you talk to many different scientists, the jury is still out on this one.
Yeah.
Were they primeval? Were they before? Were they?
Yes.
Yeah.
Absolutely. Primeval black holes, these theoretical black holes that have been around basically since the existence of the universe, that are sort of the size of an atom but still having the mass of an asteroid. And the theory says that they should exist, but they've never been observed, and we've never seen anything to think that they actually exist. It turns out there is another way. And let me just have a look at this. So this concerns a discovery of a black hole in a triple system. Now, what do I mean by this? Well, let's establish, first of all, where we are. We're at a star system called V404 Cygni, 8,000 light years from Earth. And this particular system was discovered back, I think, 1991, if I remember rightly. And there's something odd about it. And now, with the aid of Gaia data from Gaia, the European wonder machine that is creating the best map of the galaxy in 3D that we're ever likely to have, and hopes to eventually catalogue over 1 billion stars in terms of their type and distance and luminosity and all the rest of it. And there is something very strange about this system. So this is the first stellar mass black hole found in a system with 2 stars. Now, some of the media have been saying it's a triple star system, but it's not. It's a double star system, a binary system with a black hole. And both of these stars actually orbit the black hole, as you might imagine. But it gets a bit stranger from there. So one of those stars orbits the black hole so closely that its year is 6.5 Earth days long, which, as you can imagine, is very close. The other one, though, orbits a much, much bigger orbit, 3,500 astronomical units away, 3.5 times the Earth-Sun distance, and its year is 70,000 Earth years long. So that's pretty crazy. But then astronomers have found with the Gaia data that the outer star, the one that takes 70,000 Earth years to orbit around the black hole, is 4 billion years old and is well on its way to its red giant phase. We don't know a lot about the other star. But why have we come to this talking about the origins of black holes? Well, really weirdly, there's no evidence of a past supernova in the system. There's no debris from a supernova. A supernova has basically never happened in this system. So how did the black hole form? Well, what they think happened is that it spontaneously collapsed. So there was another star in the system that reached the end of its life, and instead of forming a supernova explosion, instead of exploding, it actually collapsed directly into a black hole. Now, this process has been theorized for a long time, but this seems to be the first ever direct evidence that black holes can form from the spontaneous collapse of a star at the end of its life, not a supernova explosion and then the collapse of the core of the star. So this is quite a big deal, really. And astronomers are very happy with this result. That black hole, incidentally, weighs in, it's quite a, as black hole goes, quite a lightweight. It weighs in at 9 solar masses, which is above the minimum you might expect from a black hole, which is around 5 solar masses. So not a huge black hole, but the fact that it seems to have formed from a star, instead of exploding, collapsing spontaneously into a black hole, is great. And it's the first evidence that this process actually exists. So we now move on to somewhere else. Right, what are we looking at here, panel?
This is the, isn't this a side view of the Milky Way? Looking towards the center.
It looks like embers in a fireplace to me.
It does, doesn't it? It's a remarkable image. This is the center of our Milky Way galaxy in radio light. This is what we're looking at. Now, the bit I want to highlight is the so-called radio arc, which is, I've just highlighted for you there. It's that vertical thing running down there, the big thick vertical thing. That is a long arc, obviously many, many light years long, of radio waves. Nobody knows the origin of this. In fact, nobody knows the origins of all of those other wisps and streamers and things in the picture. These are all waves of radio energy. Now, what's happened here is a really remarkable discovery. And that is to say, they found the most powerful gamma ray emitter in the galactic center. Something in the center of our galaxy is producing incredibly powerful gamma rays, the most powerful gamma rays ever seen coming from the galactic center. Obviously, the first thought, because it's near the center of the galaxy, is that it's somehow connected with Sagittarius A star, the supermassive black hole. But it's not. It's actually coming from a little bit away from the galactic center in the radio arc that I showed you. And there's a point source somewhere in there that is pushing out incredibly powerful gamma rays. There are no supernovae or any other objects visible at the source of that gamma radiation. Supernovae can produce gamma rays, obviously, because they tend to black the complete electromagnetic spectrum when a supernova goes off. But there's nothing there. And these gamma rays have energy levels exceeding 100 tera electron volts. Now, that may not sound incredibly amazing, but that is an incredibly high level of energy and exceeds by probably a few million the amount of gamma ray radiation that we can manufacture here on Earth. This is an incredibly powerful source of gamma radiation, and we don't know what it is, and there doesn't appear to be anything in the sky at that point. So this is a bit of a mystery. This discovery was made using the high altitude water Cherenkov observatory in Mexico, also known as HAWK, not surprisingly. What this is high on the mountains in Mexico. It's just a series of tanks containing water, big tanks. I forget the capacity, but it's hundreds of liters. And what happens is when one of these gamma rays, which, if you like, is a nucleus, an atomic nucleus, that's basically what gamma rays are. When it passes through the water, you get a flash of light, which is, anybody know the name of that light? No? The clue's in the title. It's Cherenkov radiation. You see this when you look at photographs of atomic reactors. You see the blue glow coming from the fuel rods, and this is Cherenkov radiation. It's this glow caused by high energy particles. In the case of a nuclear reactor passing through the water, and in this case, they can use very, very sensitive photo multipliers to see these very tiny flashes from gamma rays. And this is an amazing discovery because it's a mystery, because we don't know what on earth could be producing that much gamma radiation, especially when there doesn't appear to be any object in the sky that we can see. And because of this phenomenon, this place where this is coming from is known as a pevatron, which is where you get these incredibly high energy particles being accelerated and accelerated and accelerated as if they were in a particle accelerator here on Earth. And those phenomena are known as pevatrons. They are naturally accelerating and accelerating and accelerating atomic nuclei and other particles, which they then spit out in our direction. So that's a mystery for the future, obviously. But, we thought we were just getting to know the galactic center, which has turned out to be far more complicated than anybody ever realized. But, nature throws us yet another curveball. So there we are. So that's the news for today. Anybody got any questions or comments?
Oh, you haven't done the Euclid one.
No.
Sorry?
You didn't do the Euclid one.
Did that not come up? Okay, let's go back to Euclid. Just give me 1 second. I must have premature. Just 1 second. I must have ended prematurely. Not to worry.
Well, while you're bringing that back, I do have something I want to mention. You mentioned that gamma rays were particles, and my understanding is gamma rays are actually electromagnetic radiation and not the standard particles.
They normally are. In the case of these pevatrons, they accelerate atomic nuclei. That's why they're called pevatrons. They act like a natural particle accelerator. Yeah. Okay. I can see you're a bit confused. But anyway, that's what they are. So let's just go back to the Euclid. Yes, Euclid. Now, the Euclid is a European telescope that was launched to study what's called the dark universe. That is to say, dark matter and dark energy, about which we obviously still don't know very much of the nature of either of those. And Euclid eventually aims to map a third of the sky in an effort to try and find out what dark energy and dark matter. They're two unrelated phenomena, we think. They're two distinct phenomena. Dark matter, of course, being the majority of the matter in the universe, and we don't know what it is, and we haven't known what it is ever. And the dark energy, of course, being this mysterious force, if you want to call that, that's causing the universe to accelerate as it's expanding. So this is the first release of some of this data from Euclid. You can see in this image, the bit I've circled, that's how much of the sky the image comprises. So if we now have a look at that, this is the image that's been released by the Euclid team. And it represents a very tiny part of what will be the eventual mapping of the night sky. Now, this map will be in 3D because Euclid is able to manage to measure distances. So it's a 3D map of a third of the night sky. And this part of it is just 1% of what Euclid will eventually end up with in terms of data. And in just 2 weeks, Euclid covered 132 square degrees of the southern sky. That's more than 500 times the area of the full moon, as seen from Earth. And the full mosaic, that image is 208 gigapixels inside. Now, it looks great. What's in that image? And this image actually contains 14 million galaxies and 100 million different sources of light of one type or another. And the idea is that by building up this map over the next few years, Euclid will be able to give us some really interesting clues about the nature of the elusive dark matter and dark energy. So we will see. There is, if you look this up on the web, there are some sites where you can actually go and zoom into this image. I haven't had a chance to do that yet, but you've had a look at that, haven't you, Daz?
Yeah, there's a YouTube video.
Oh, is there?
Which actually zooms in and when well, I'll tell you, my jaw dropped. It was as simple as that.
Yeah, the zoom in picture was absolutely amazing.
Yeah, it's I mean, you like you say, you look at this picture, then it zooms in more, then it zooms in more, and then you can see individual galaxies.
Yeah.
And you can actually zoom into these individual galaxies, and it was absolutely stunning. The resolution was fantastic, and this is going to create so much. Well, it's going to increase our knowledge because it's like again, it's doing time-related events, so that we can actually see things moving. We can actually see, because isn't this supposed to produce a sort of like a cobweb of the galaxies in the end, in the dark matter?
Yeah, that's
in the end. That's the idea.
That's right.
So,
that's absolutely right. Yeah. It's Euclid is amazing. I think we covered the launch of it live, if you remember.
Yeah. It was, and of course, as soon as this came out, and like I said, I saw this video, it was fantastic. Like I said, if you go onto YouTube, just look for Euclid first movie images, and you should be able to find it quite easily. But it's jaw dropping. It really is. It really is fantastic.
Yeah,
absolutely.
Well worth a watch.
Yeah. Okay. Right. We're going to move on to talk about this Elon Musk city on Mars. But before we do that, Brian and I have been having chats about the value of preserving astronomical media, because is there anybody in the panel who hasn't got collections of old astronomy books and magazines and things? Because I think we all do it. Yeah.
Yeah.
I have
Stacks of
sorry.
stacks of magazines and things like that.
Yeah.
Astronomical magazines.
Yeah. Unfortunately, a lot of mine have to go. Unfortunately.
Yeah.
So yeah.
I mean, I think, you know, those of us who have got partners under constant pressure to get rid of all that old tat, yeah? Like,
Hey, look at that.
Anyway, so
Pretty good.
Brian has been, we've been talking about slides, or as they used to be called, transparencies.
Wow.
Right.
And Brian, do you want to put out an appeal for what you're looking for?
Yeah, I'll just tell you how all this kicked off. I am at the moment, temporarily at least, booking all the speakers for the York Astronomical Society, and I filled the whole of 2025 apart from one date. And Martin Dawson of the York Society, I don't know whether anybody of you know him.
I know Martin.
Yeah, brilliant. I mean, I've known him since the 70s. Yeah, great.
Yeah.
It's brilliant. Anyway, the point is, he says, you want to get Dave from Darlington. He usually gives a really good talk. So I phoned up Dave from Darlington, and I said, you've been recommended, young man. I didn't know how old he was. Turns out he's as old as me. So I stayed with the young man bit. And I said, I've been asked to book it for a talk at the York Astronomical Society. And he said to me, well, my PowerPoint skills are non-existent. I thought, well, you know, join the club. He says, and all my slides are in the loft. So I thought for a second, and then the cogs started spinning. I thought, well, I tell you what, how about giving us a slideshow? Let's go all retro. Wow. Yeah. And so he's up for it. And I told Martin this, and he says, oh, God, I'll give him one as well next year. So we're getting 2 slideshows next year as opposed to PowerPoint. And then I said to Martin, I says, look, let's take this a stage further. Let's try and put together a lantern slideshow. Ooh. And it turns out that Martin's got knocking on for a dozen lantern slides. And I thought, well, why not? You know, just go for it. And it turns out there are more of these things kicking about than people imagine, because they were made in their absolute thousands back in the early 1900s, whatever. And they, I'm buying some off somebody next week. I think 39 astronomer related ones next week. I'm picking them up. And I've been talking to 1 or 2 people, and we're sort of, I'm trying to build up a collection, mainly to save them and make sure if I shuffle off this mortal coil tomorrow, we're in 30 years, make sure they go to a good home where they will be preserved. And I've got the Society for the History of Astronomy in mind for that. There's a contact there, but we'll probably, you know, whatever. But so basically, what I'm trying to do, and is to say to people, look, if you've got any 35mm astronomer-related slides that you don't want, don't throw them away. I'll give you my address, you know, and you can post them, and I'll even buy them off you, you know, or at least pay the whatever. And Andy has actually sent me, and this is an interesting twist, actually. So talking about you, Andy, he sent me Einstein's Universe, a set of 19 slides, which were used for you to give a talk on Einstein's Universe many, many years ago.
1986.
86. And the script is lost, but the slides are there in order. So what I'm going to do is I'm going to put them on at the York Astronomical Society and say, I don't know what's coming next. So I'll tell you what, this talk is called Einstein's Universe. So let's have members of the audience doing the narrative for each slide, imagining how it fits into the whole scenario.
I think it's a great idea.
Yeah, it's going to have to be a complete disaster, or it's going to be a right laugh, or it's actually going to be quite informative. We just don't know, to coin a phrase. And so, yeah, so we'll see how it goes. But I will. Your request this morning, can we film it? This debacle, and so I'll ask them to film it, because they do sometimes film some of the speakers. So if I won't be a speaker, you see, I'll just be waving my arms at I'll be the gob on the stick. And it'll be everybody else who'll be joining in, and it'll be different.
Well, that's a sort of a spontaneous do-it-yourself talk with the audience, providing information. That'd be brilliant.
Yeah, well,
and,
we hope so.
Yeah, so
if anybody out there has got any 35mm slides or even lantern slides, please do get in touch, and I'll talk to you. And if you want to sell them or give them away, whatever, that's it. I mean, if I use them to give a talk, I never charge for my talks. So there's not even a hint of profit making or anything in this. It's purely for the joy of holding them temporarily, looking after them, and preserving them for future generations. And that's basically it. So please do get in touch if you've got any at all.
Does that include medium? Ryan,
sorry?
Does that include medium format slides as well? The 2 1/4 square, the larger lantern slides.
Yeah, the lantern slides are 3 1/4 glass slide.
Yeah.
Includes those as well. So it's the lantern slides and also just the bog standard 35mm slides. Yeah. And at the York Society, they happen to. Has anybody ever heard of Neville Kidger?
Yeah.
He was a real authority on space flight. He had a collection of slides. Yeah. And we've actually got his slide projector.
Oh, right.
So that will be given on Neville's slide projector, which is quite emotional. Neville once did it turned into a 26-hour non-stop, apart from the statutory short breaks, talk on space flight in the centre of Bradford to raise funds for the Bradford Society. He talked on space flight for 26 hours back in about 1991 or something. So that was quite, indeed. So, so there you go. So, lantern slides, 35mm slides. Please do get in touch. But whatever you do, don't throw them away or whatever. There, I'll get off my... So
absolutely. And if you do manage to film it, Brian, we could show at least some of it here if everybody consents to it, of course. Because that'd be really interesting exercise for the audience. Make up the narration based on what you see on the screen. So that could be really fun.
To be honest, the York Society, the members of the York Society, there's a lot of the members that are seriously knowledgeable, and I can see this going, actually developing quite a theme. I can see the slides traveling around different societies. So whichever, So anyway, there you go.
Well, I was actually looking. After our conversation, I was actually looking to get a slide projector because I've got about 60 or 70 slides that have been stuck in a box for 40 years, and I'd like to actually see them. And holding a few up to the light, I could see I've got sort of really old family things from my niece and nephew when they were children. They're now adults, of course. So, but I was looking at the price of slide projectors. I mean, they're just astronomical, if you'll forgive the phrase. They're really, really expensive. So, but I remember my mother had a handheld slide viewer, plastic thing with a plastic lens.
I've got one of those.
Yeah, so if I can track one of those down at a reasonable price, I think I'll get one.
In the
my
chat,
mother actually had one, but of course she has no idea where it is. So, so there we are.
In the chat, Sandra's saying you can get a little machine that transfers it to PC. It's very simple to use, apparently. So.
Yeah, absolutely. And Keith's come up with something useful, Brian. Reslides 35 lantern. Contact the SHA. I was talking to a member at Saturday's meeting who had worked at Liverpool Uni. They have recently had a clear out, and he had lots and lots. So,
right. Well, I have contacted the SHA, and the guy who looks at the lantern slide collection is hopefully coming to give a talk in York at a convention sometime in 2026.
Oh, right.
I don't want to give his name away because I shouldn't really, but essentially he's got the script of a PowerPoint slideshow that Robert Stowell Ball gave about 100 years ago. And it's trying to put together a full set of lantern slides to go with it so he can give the talk exactly as Ball did in the circa 1900.
Right.
That is fascinating. So yeah, it seems I've stirred up a lot of interest with this, which is brilliant because it's good.
Another message for you from Derek. I've just looked on eBay. There are 120 slides ranging from £5 each.
Yeah, people for some reason, the prices people charge for astronomer-related glass slides. I was told, I forget who told me, says people will try and on eBay and so on and Amazon, they will try and take money off you for them, as it were, more than they're actually worth. But I don't know. That seems to be borne out. But yeah, so I mean, I'll just go for what I can. But that's it. Yeah. So we'll see how it develops.
Yeah. Okay.
Yeah, not pun intended. Oh yeah, wish I had. Yeah.
I saw a slide projector on eBay. Somebody in the States was selling it, and it was $5 for a slide projector. But of course, when you look in the small print, $119 postage.
Yeah, very good. So the person, by the way, who mentioned that he'd seen something at the SHA, if they can put me in touch with that person, that would be appreciated. I don't know who it was that put the message up, but they'd seen something at the SHA at the weekend.
It was Keith Pearson. Hang on, I'll put it up again for you, Brian. Yeah, it was Keith. Keith, if you could liaise, how are we going to do this? Send an email to us, Keith, if you'd be so kind, at spaceodditieslive@gmail.com with the contact details of the person who might have the site, and I'll forward it to Brian. So, yeah, great. Thank you so much.
Yeah, I think Sandra's offering her 70s Spain holiday photos if you want them, Brian.
Yeah.
Astronomical.
I'll look at anything.
It's appreciated. It's appreciated.
All right.
Brian, you might want to try local photographic societies as well. They might be able to help.
But what is it about astronomy?
Good idea.
Yeah.
Yeah, good idea. What is it about astronomers where we haul all this stuff? I mean, it's not just astronomers, is it? It's just men in general, I think,
Yeah.
We're
telescopes and things like that.
Yeah, we hoard things, and because for example, I must have. Oh God, I've got about 80 editions of Omni magazine. I've got dozens and dozens of various astronomy nows and skies and telescopes and astronomy magazine, and they're just too beautiful to throw away.
You never know, You never know when you need it.
Exactly.
Well, you do, don't you?
Wow.
This book here has actually got a handwritten letter from John Herschel in it, and it's the first publication of Herschel's.
Really?
Gosh. Yeah. And I picked it up in Hay on Wye for £5.
Honestly,
I had it valued, and it was valued at well over £5,000.
Wow.
Right. What's your address again, Pete? What's your address again?
I'm not telling you I'm in hiding.
We had that situation.
I got a whole library of antique books from 1700 upwards to about 1950.
Yeah.
Wow. You mentioned Sky and Telescope magazine. I'm building up a collection from the first issue, November 1942, through to say 1980. So there's a full paper collection in this country for archival purposes in the future. Because at some point, the electronic means of reading these will just go defunct. But guess what? The paper copy's still there. And I'm missing a few from the 50s. So if anybody's got any spare 1950s Sky and Telescopes, that would be that I would be interested to hear from them as well.
Okay.
I've got some interesting to tell about that on another day.
Brian, Keith says he doesn't know the chap's name, but leave it with him and he'll find out. So if you could do that, Keith, if we could just ask you to send an email to spaceodditieslive@gmail.com, pass it on to Brian. So there we are. So everybody's happy. Everyone's a winner. Fantastic.
Yeah.
Right. Okay. Well, let's move on now to tonight's main feature, if you like. So just to set some sort of context in this, about 2 years ago, Elon Musk first made the claim that SpaceX were going to build a city on Mars for 1 million people by the year 2050. Now, you know, I know what we all think of that, but I thought it'd be good to just have a look at why that's not going to happen and the issues involved. So just give me 1 second, and I will sort it out. Okay. Okay, hope you can all see that. Mm-hmm. So let's go into this. Now, listen, the whole thing about setting up a base on another planet, it's incredibly complicated and involves lots of different disciplines: science, engineering, health, you name it. It's a very complex operation, and we don't know yet exactly how it's going to be done. Obviously, we want to see people living on Mars. Obviously, we want to see some sort of permanent moon base established, because I'm with Elon Musk on this. We have to make humans multiplanetary, because the Earth could be wiped out next week by an asteroid. We could have another pandemic that you know, unfortunately would wipe humanity out, or most of it. We are very much at the mercy of the universe on this tiny little ball of rock we live in. And if we can make ourselves multiplanetary, if we can set up base on other worlds, it means that the human species is not probably at risk of extinction. So I agree with Elon about this, the imperative to do that. And it is an imperative because, you know, with the pandemic, we saw how an out of control virus can have devastating effects on the world. We think we've mapped most of the dangerous asteroids that might cause danger to the Earth in the foreseeable future, but you never know. We haven't got all of them, and there are undoubtedly asteroids out there that are potentially dangerous that we don't know about yet. So, as I said, in 2022, Elon Musk said, we plan to build a city on Mars which will house 1 million people by 2050. Now, this wasn't one of Elon's whims, if you like, because he has actually since formed a SpaceX team dedicated to researching this, building this Martian city and working out how it could be done. So he's serious about it. And, you know, as I said, I do applaud his motivations in wanting to give humans some sort of insurance policy on another world. Now, this is his plan, and he was talking about this only last week. The plan is to send, first of all, send 5 uncrewed starships carrying cargo, things that human explorers will need, to Mars during the 2026 launch window. As you may know, there's a launch window to Mars every 2 years when Earth and the Mars come close enough that the trip will be down to about 6 months. Then he wants to send a crew of people to Mars, again on a starship, during the 2028 or 2030 launch windows. And then the easy bit, build a city. So let's have a look at these. First of all, this plan to send first 5 uncrewed starships to Mars during the 2026 launch window. Now, this, I don't know if you know how Starship works, but we've seen Starship launching into orbit, or certainly on a ballistic trajectory. And if you're going to send it further, if you're going to send it to the moon or Mars, it needs refueling, but because by the time it gets into Earth orbit, its fuel will be severely depleted. So to do that, you send up another starship and transfer fuel between them. So don't forget, we're talking about 5 starships in the planned 2026. So each refueling operation will take not 1 starship to refuel it, because that starship carries fuel as well that it needs. So you can't fill it full of fuel for the departing starship. And it requires between 10 and 15 starship launches to refill one of the 5 starships. So what does that mean? It means that there will be somewhere between 50 and 70 starship launches required to fully fuel all of those 5 starships for their Mars journey. This is a lot, but what it also means is this: if you've got a starship hanging about in orbit, its cryogenic fuel will boil off, because that's what happens because of the low pressure. So what you need to do, you need to refill those starships as quickly as possible before you lose too much fuel to make the journey worth it. So to make sure the fuel doesn't boil off in a large quantity, all the refueling would have to complete within a maximum of 2 weeks once the starships get into orbit, these 5 starships, and at most 2 weeks, and ideally within a few days. And what this means is if you go for the 2 weeks, which actually is probably too long a time to keep that starship in orbit before it's refueled, but let's take 2 weeks, and that would mean 4 or 5 starships launching every day for 2 weeks, with each having to perform flawlessly with no problems in order to refuel those 5 starships for their Mars trajectory. Now, as you know, in just over a year and a few months, they managed to launch Starship 5 times in a year and 3 months. Yes, granted, a lot of those delays have been regulatory delays, but even so, they've got to get Starship up from a launch cadence at the moment of once every couple of months to launching 4 or 5 a day, and do this before 2026. The problem is that SpaceX are not expected to begin experimenting with orbital refueling until the middle of next year. So already we're in the middle of 2025 before they even start actually trying orbital refueling. And this is going to take a lot of time to get right, because undoubtedly there will be problems that they'll have to change the design of the system and the spacecraft or whatever it is. There are additional factors, not just to do with the refueling, that will actually make that launch cadence very, very difficult, meaning that this 2026 launch window is almost certainly going to be missed. And of course, there's something else going on at the time. SpaceX had contracted to land people on the moon on the Artemis 3 mission around 2026, 2027, although latest indications are it's probably going to slip back to 2028. But in any event, NASA are going to insist that SpaceX concentrate on doing that because they're contracted to, rather than mess around trying to get ships to Mars if push comes to shove. So this is all highly unlikely to happen in 2026. That time scale is just not really realistic. Let's assume then that they managed to send 5 starships to Mars. They've got to land. Now, landing on Mars has traditionally been a really difficult activity. There have been lots of failures. Don't forget, over 50% of all the missions sent to the Red Planet have failed. The Red Planet does not like us, putting it simply. NASA have tried various methods to get those spacecraft onto the surface. Those have been meant to land, of course. And they've tried everything from airbags, which they did with the Spirit and Opportunity rovers in the 90s. That worked fantastically well as a delivery system. You may remember those airbags that bounced across the Martian terrain for a few years, having been dropped by for a few miles, having been dropped by parachute. But those rovers were quite small, and I don't know how much they weigh, but it wouldn't be a big amount that they weighed. Starship would weigh around 180 tons. So you somehow got to get a Starship weighing 120 tons down through the Martian atmosphere. You can't use parachutes with something weighing 180 tons because they would be probably, I was doing some calculations, probably nearly 100 times bigger than any parachute ever built. So that's not going to happen. Also, you may know that NASA have used parachutes to lower the Spirit and to lower the Curiosity and Perseverance rovers onto the surface of Mars, but they only weigh a ton. And NASA have experimented with the same system for heavier rovers, or potentially heavier rovers in the future, just using dumb weights to simulate them. And they've tried lowering in a simulation 3 tons using the same method as they use for Curiosity and Perseverance, and it didn't work. So around 1 ton seems to be the maximum that you can deliver onto the surface of Mars with the aid of parachutes. So how is SpaceX going to do this? Well, the Starship will enter the upper atmosphere of Mars, traveling about 12,800 miles per hour. And you've got to get that speed down to near zero for landing, of course. And it takes about 7 minutes, which are known as the 7 minutes of terror. It takes about 7 minutes to descend through the Martian atmosphere. And you're familiar, if you know Starship, you know that it comes into the Earth's atmosphere horizontally, and then at the last moment fires its thrusters, which then swing it round into a vertical position, and a landing burn is done, and it lands, and that's known as the belly flop maneuver. This isn't going to work on Mars because Mars' atmosphere is only about 1/100th the thickness of Earth's atmosphere, so that's not actually going to work. The only way it could work is if they do that belly flop maneuver a lot higher up in the atmosphere, and then fire the engines for the landing burn for a lot longer. But of course, that means a lot more fuel. So the whole system would have to be redesigned. And at the moment, SpaceX have not said at all how they're going to do this, how they're actually going to land these starships on Mars. So this is another big problem. So part 2, send a crew to Mars during the 2028 or 2030 launch windows. What will actually be needed for this flight to Mars in terms of resources? Now, let's first of all assume that the trip is going to be 3 years. That is to say 6 months to get there, 2 years on the surface until the next launch window. So those astronauts are going to be on the surface of Mars for 2 years. There's no getting around that. It's not an option. They will be there for 2 years until the two planets are close enough together again to launch back to Earth, so that you've got a 6-month journey instead of a year's journey or whatever. So you've got a 3-year round trip. Let's first of all talk about water. Now, obviously, they're going to need to take water with them. The first missions, and probably a lot of missions, will not be drilling for Martian water that we know is there, but they're going to have to take water with them. So if you assume a water consumption of 2.5 liters per day per person, during the 3-year voyage, that makes you've got to take 16.4 tons of water with you, if my calculations are correct. Now, one Starship has a massive payload. A Starship typically has a payload potentially of about 100 tons. So that's not going to be a problem so much. However, you have to make sure that, you know, that water is still drinkable after 2 years, and that you don't spring any leaks. So it's a bit of a precarious situation with the water. If we talk about food, 6 astronauts would require around 12 tons of food for a 3-year voyage, based on 1.8 kilograms of food consumption per day, which is what NASA recommend. How are you going to keep that food fresh, nutritious, and varied? You'd have to give the astronauts a varied diet. They go insane if you didn't. So you can't use anything except the usual astronaut freeze-dried food. Well, why not? Well, there are alternatives to taking freeze-dried food. You could, of course, build greenhouses to grow food on the surface of Mars. And you could also, who's got an echo on the sound there? Somebody turn that off, please. You could also use hydroponics, which is another technology, basically growing plants in water, as you probably know. Yeah, okay, these are methods of growing food, but neither of those techniques are advanced enough at the moment to be able to support 6 astronauts for 2 years on the surface. We assume it's going to be 6 astronauts. I think that would be the minimum size of a crew that you could send to Mars, because you would need to take a surgeon with you if somebody gets ill. I can't see it being less than a crew of 6. So this technology exists, but it is in its infancy, and it's never been done in Mars gravity. Obviously, Mars gravity only being 38% of the Earth's gravity. It's never been done before. We don't know on that scale. Anyway, NASA have done experiments on the International Space Station with this sort of stuff, but only very small scale. And they're not far down the road to making it a viable proposition. Of course, you'd have to build those food production facilities before you can grow anything anyway, once you get to Mars. And could that be done by 6 people? We don't know. That would be highly unlikely, I think. So where would these astronauts actually live on Mars? Well, I don't think that they've got an option. Certainly the first mission, they would actually live on the Starship. So this gives you some problems. You say, okay, they're protected from the dreadful solar radiation that you're exposed to on the surface of Mars. That's fine. They're protected against the radiation. So what are the problems? Well, the problem is the power, because you can't rely on batteries that are going to run for 2 years. They just don't exist. Or at least if they do exist, they're massive batteries the size of a house. So you can't really use batteries to provide power for the astronauts, for their oxygen, for their life support, for everything else. You'd have to use solar panels. You'd have to actually get off the Starship and create an array of solar panels. The estimated size of that area to supply power for 6 astronauts for 2 years is 1,000 square meters. That's a big solar array. Now, if you can imagine astronauts out in spacesuits working in 38% of Earth's gravity, how many hours a day would they be able to work? Would they have the stamina to do the work? We don't know. This is all completely new, of course. So you can't really even work out a ballpark figure of how long a 1,000 square meter solar array would take to build. But I think, realistically, you're looking at several months. This is not something you can knock up in a weekend. So this is a big problem as well, because it's unlikely that this solar array could be built to provide them with power for 2 years. Theoretically, you could send robots up. Now, Elon Musk actually talked about this. Yeah, we'll send robots in advance of the humans and they'll build everything. Well, no, they won't. Autonomous robot technology to get out there and build big things like 1,000 square meter solar array, those robots don't exist at the moment. We haven't got the technology to do it. Small scale things, maybe. Tiny things, maybe. But big projects, the robotic technology is not there at the moment. In a few years, it may be, especially with AI. But at the moment, we can't send robots to Mars that are going to build autonomously and without problems a solar array of 1,000 square meters. It's just not going to happen by 2026. It's absolutely impossible. So this is the Martian city that Elon Musk envisages. As you can see, it's very grand, but of course there are problems. So I think SpaceX, obviously, Elon's been very, very vague about all this because he doesn't know. So this would grow out of obviously smaller settlements, and those would have to be established for many years before you could scale it up to the size of a city. Unless you reduce that 6-month transit time, you're going to find resupplying a Martian base of even 20 people very difficult and costly. And we're talking about bases that, for, I don't know, 10, 20 years would not be self-sustaining, because that takes a long time to achieve. So you'd have to resupply them from Earth. Now, you could say, well, the city wouldn't be built until, the existing bases on the surface were self-sustaining. How long is that going to take? And there's more, because if you build a city for 1 million people, that's going to take decades, given the harsh and dangerous environment about which we know not a great deal, what it does to humans. And of course, it's never been done before. But do you know how much food a city of 1 million people would consume per year? Well, after I did some calculations, it works out that 1 million people would consume around 500,000 tons of food per year. Resupplying that would be impossible. Growing that amount of food on Mars, I would suggest, for the foreseeable future, would be absolutely impossible unless you go into terraforming Mars so that you can grow plants outside as we do on the Earth. But that is hundreds of years off, if it ever happens at all. So basically, none of this is going to happen. And the biggest question that Elon Musk hasn't answered, who are these 1 million people who would want to go and live on Mars? There can't be 1 million people in the whole world that would want to go and live in such a dangerous environment. In my very humble opinion, the only people that are going to live on Mars will be engineers and scientists. And Joe Public going to Mars to live, I think, is a fantasy for maybe hundreds of years. I'm sure in the far future it'll change if we manage to survive this century as humans. Or the way it's going is not looking good. Sorry to be so downtrodden about that, but it's true. You know, humans have got a lot of very difficult issues coming up very shortly on this planet, and unless you could give people a reasonable living quality on Mars, they're not going to go. You have to give them something to do all day. You'd have to provide jobs and a whole economy and industry and everything else. This is far in the future. We haven't got the wherewithal or the technology to do this at the moment. So there we have Elon Musk's Mars City. So let's just finish up by saying, will SpaceX send 5 starships to Mars in 2026? No, they won't. Will SpaceX send a crew to Mars in 2028? No, they won't. Will SpaceX build a city on Mars for 1 million people by 2050? Well, you're kidding. Absolutely not. And what is the timescale for a permanent resupplied Mars base? I would say 15 to 20 years, we may have a permanent base on Mars, but it's definitely not going to happen within the next few years. And that assumes, of course, that the money is there and the political will to do it is there. But as I say, humans have got a lot of problems on this planet to sort out before I think there'd be any serious attempt to permanently create a base on Mars. So there you are. So those are my thoughts. Anybody got any questions or comments?
Andy.
Yeah.
Right.
Oh, yeah, it's a very quick one. This is kept amongst the pigeons, and you can take it as you want. But why don't you invite Elon Musk to come on Space Oddities and explain how he's going to do it?
Yeah, that would be good.
No, seriously, because if you invite him and copy everybody else in, he can't say he hasn't been invited and given the chance.
Yeah.
Well, that's a good idea. Perhaps we'll have the audacity to do that, Brian.
Well, if I had his email address and you could word, I don't mind sending it, you know. Yeah, why not? There's one thing I've learned. If you want something, ask for it.
Yeah.
You know, you don't get anything unless you ask, apart from tax bills. But you know, but that's it.
A few years ago, before I retired, I was involved in a conference, and it was about sending people to the moon and to Mars to live. And they were looking. Obviously, they've been looking at it for years, but they know how impossible this is at the moment. But one of the conversations we had was with solicitors, and there are solicitors assigned to looking at laws when you go to another planet to live, or the moon. And one of them is, if you've got a group of people living on Mars for 2 years, let's say, and this came up as a valid conversation with NASA and with ESA. If you've got a group of people living on Mars and somebody commits a crime, whose laws do you abide to, and how do you implement them?
Yeah.
Good.
There are so many things, and the other thing we were looking at is obviously the health aspect. If you send a group of people to Mars, you've got to send a doctor or a medical professional, because if somebody falls ill, you can't just slip back to Earth and go to the hospital.
No, they'd have to send a surgeon.
Yeah,
and a doctor.
So there are so many aspects to this.
No.
But the law one is a good one. If you've got a group of astronauts and one of them goes nuts, and what do you do with him?
Yeah.
I think with the law thing, it would revert to something like maritime law.
Yeah, but again,
Roger, you up? Pirate law.
Yeah, pirate law, Roger's law.
People
at the end of the day, who implements it? Who decides on it? Who is judge and jury? There are so many aspects. Also, you've got the psychology of people living together. You've got to make sure you get the right group of people who actually live together for a long time.
Yeah.
Because one thing they didn't do in the Apollo times was do the psychology of putting astronauts together, because, like I said, I knew Neil Armstrong very, very well. And one thing they didn't do was look at how Buzz Aldrin, Neil Armstrong and Collins will get on. And they didn't really get on as friends at all. And so they looked at this now with the space station, when you send crews to the space station, they have to look at their psychology and how they will behave with each other. So there's so many aspects to look at, which
Well, you know,
without
I said at the beginning of that, Pete, it's such a complex undertaking. It touches on so many different areas. Aaron, I think you wanted to say something.
Yeah, I was just going to say, Andy, I don't get to your million people quite, but you mentioned engineers, you mentioned scientists, and then to that you can add astronomers.
Yeah,
But I still think we're probably shy of 1 million.
Andy, and another thing, Andy, when you were talking about the amount of food to take with them, what about the waste as well?
Yeah.
And what they're going to do with it?
Yeah.
They haven't got incinerators on Mars, have they? So
Very
exactly. So what we're going to do? How are we going to destroy the Martian environment like we are? Yes.
Oh, they'll do the same like they did on the moon.
Yeah.
Or the same as
oil
done on
heat.
Earth.
It was. It's not really. I mean, if you are doing agricultural, then again you can go down the Martian route.
Yeah.
And you can use it as a form of fertilizer and nitrogen.
Yeah, that's right.
But I was thinking more of the fact that one, like I said, we need more details of how this is going to work because I think it's GPS that Elon uses for positioning of his starships on their landings. Well, he's not going to be able to do that at Mars because there aren't the satellites there.
No.
But also, would they use sort of like the Japanese do, where they've got millions of photographs of the surface of the moon, and it's basically a camera will look at the surface of the moon and it'll recognize exactly where it is. So that's something else that we've got to have the technology to be able to land these things. But then also, I mean, you said about a return journey. Would it be a return journey?
Yeah. I think the first mission would be. I can't see on the.
It'll have to be.
There wouldn't be the infrastructure on Mars for anybody to want to stay there on the first mission. They would be coming back.
Look at the moral.
Yeah, well, exactly. That's the idea. But from what I understood, what Musk has said in the past, that it wouldn't be a return journey.
Yeah, but look at the moral implications of that.
Yeah.
This goes back to Pete's. You've got to look at the psychology of people.
Yeah, the psychology of people at the going, the psychology of their families as well. Their relatives back on Earth.
Yeah.
And they're not.
Well, you'd have to. This is the whole thing, but I don't think it's a guarantee. And like I said, it would be nice if you could do a return journey, but then again, you've got to look at the fuel situation as well, because as you were saying, you get boil off. You're still going to get boil off while you're still sat on Mars. So if you're waiting, 2 years or whatever, then you're going to be losing fuel left, right, and centre.
Sure.
I don't know how it's going to work. I mean, first of all, we've got to do these things on the moon, and at the moment, that looks very unlikely. That's going to happen in the next sort of like 2 or 3 years, if it happens at all with Artemis. But when you start looking at this, I mean, Pete's right with the legalities of all this stuff. It's with and one of the big problems is when they did the 1960s space treaty, it was space for everyone, and nobody could claim any planets or asteroids or anything like that. But this is all voluntary. But if you remember when Mr. Trump was president last time, and he decided he was going to have all his Buzz Lightyears, then he was going to send them to the moon. They were going to make a base on the moon, and he was going to put exclusion zones around the moon. Now that is, putting a stake in, isn't it? You're claiming that part of the moon, and so the legality of it all. I mean, we're jumping ahead a little bit with legalities. Who owns what and other. But the thing is, I think the logistics, they've got to really start coming up with some really solid fuel. Liquid fuel.
Wow.
components of how this is actually going to work.
Yeah, that's right.
Because I mean, you're talking about launching 5. Is that 5 in one go, or is it 5 one after the other?
5
Because
in one
again,
go.
because at the end of the day, you've still got to have them land close together so that they can work together. And this again then comes back to the navigation and things like that. So
yeah,
there is going to be some kind of global positioning system on the moon, isn't there, around the moon?
Yes.
And there's going to be one planned for Mars as well in the future.
we were talking about that European project to create that positioning system only last week.
That's right, yeah.
If you weren't watching Space Oddities last week, go and look at the video on YouTube, because we were talking about the European Moonlight Initiative to establish a communication network for lunar exploration.
ESA have run 5 experiments where they put people in isolation to simulate time on Mars. 5 experiments, 4 failed.
Yeah.
Really?
What happens if obviously people are going to have sex on the moon, on Mars, so get babies?
You to lower the tone.
Yes.
No, seriously. You know what happens if babies appear? You know, they're going to be like Martian babies or what?
Well, they're just going to be a pain in the arse, really.
I mean, at the end of the day, they I mean, the plan is to have children anyway up there, isn't it?
Yeah.
Because if you're going to build a city up there, you've got to be able to, reproduce and things like that.
Yeah.
So this is other things that you. But then by then, before you start having children, hopefully you've got the infrastructure there where you'll have a maternity ward or something there. I don't know.
But it's not as simple as that. It's really not as simple as that, because we don't know what 38% gravity would do to a pregnant woman, whether she would actually be able to have a child.
Kind of getting at, actually,
yeah.
At the end of the day, you can sum it up with a small sentence: Elon Musk is deluded, and leave it.
Well, I mean, I think what's happened with Elon Musk, as I said at the beginning, I do applaud his ideas that he's right that we need to make humans multiplanetary to avoid extinction, but at the same time, he's a dick. So
Well, but also when we were talking about the psychology, I was good night then, Aaron. Thanks, lovely seeing you and seeing you today for a little while.
Yeah, thanks. Sorry, I need to bug out, but carry on. I'm very pleased that I got to hear the Elon Musk story, though.
But,
take care, Aaron. See you soon.
Now.
Ta-ta.
Yeah.
Okay, then you take care. All the best.
I've
lost my thread now. What was I saying?
I don't know.
I was, but it's let's forget that. It'll come back to me. So if anyone else has got anything,
you're talking about Elon.
I can't remember what I was saying now. See, look, you get a cough and it all goes.
But what I was saying about the waste, though, for instance, on missions at the moment, they bag the waste and send it back, and it burns up in the atmosphere or whatever. There's going to be a lot of waste on the moon and on Mars.
Yeah.
So,
well, yeah, exactly.
Anyway,
but you'd have to.
Anne says, "How will they be able to walk when they arrive? When you see the state of astronauts when they come back to Earth?"
That is a good point as well.
Yeah.
But then again, like I say, just look at I've forgotten the name of it. Now that program we watched, Andy, with the belters.
The Expanse.
The Expanse.
Sorry, Expanse. Yeah, I mean that was really good. Trying to explain how different gravities. I mean, in those they were called the belters because they're living beyond Mars and things like that, and they're living on asteroids where the gravity was virtually zero.
And they, as subsequent generations were born, they were a lot taller and a lot skinnier because of the low gravity. If you haven't watched The Expanse,
sorry, I was just going to say, of course, they couldn't come back to Earth because they couldn't even breathe because the pressure was thing. So again, you would get over generations, evolutions. Okay, then, Brian. Nice seeing you again. We hope to see you, speak to you soon again.
Yeah.
Yeah.
So
Thanks for being here, Brian.
But, yeah. So
Let me know when the flight is.
take care. Bye bye.
I'll be
Take care, Brian. Bye.
Oh,
Cheers.
I remember what I was thinking about now. We were talking about the psychology. One of Carl Sagan's duties or jobs at NASA was to talk to the astronauts and try and explain to them what the possible repercussions were of actually seeing Earth from another perspective so far away, how it would affect them. And everyone who's been to space says they have come back different, just by seeing, the Earth suspended in the dark from another planet, the moon. They said it did affect them spiritually.
But can you imagine what it would be like from the surface of Mars, where the Earth is just a point in the sky that's not recognizable as
more than that, though? You imagine watching it disappear slowly but surely.
Yeah.
Yeah.
Oh, good grief.
Yeah, I mean, one of these studies now that they're going to do. Oh, sorry.
Yeah.
Sunsets
aren't the same, are they?
No, I was just saying. Well, imagine if one of the studies they're going to do with regards to the sun is they're actually sending probes to the sun and landers, and they're actually going to be looking for the effects of the solar winds, auroras, CMEs, and things like that actually on Mars. To see, because we know that when Mars is on the far side of the sun, it can get pummeled massively with huge eruptions, which we don't seem to get so much on the near side, or the side facing us. But they have, and because again, they have to know what's going on, because they have to shut down the Curiosity, Perseverance, and all of those, because they've got to protect those as well if there's a big CME on the way. So, but these things can travel very fast. They may only have, I think the fastest from the, we were talking about this the other day, the fastest from the sun to Earth, I think, is about just below 17 hours.
That's right.
I think I mentioned this before. So they can travel at huge speeds. And if they're made up of high radiation particles and things like that, it could be devastation.
And don't forget, well, Daz, it's not just the risk from the sun. Every 18 months or so, the whole of Mars is enveloped in massive dust storms.
That's right, yeah.
You can forget power generation from solar panels. Okay, nuclear generators would be a way of powering what you need. But, they'd have to be small, and they don't really exist yet either. So,
I think Rolls-Royce are involved in developing...
yes, Rolls-Royce are working on those, yes.
Yeah, are working on those sort of things, mobile, sort of like nuclear reactors. And that's the only way you could really do. Re-pregnancy, a doctor told me that if a baby hiccuped in the womb in space, it would be a disaster.
Yeah.
Okay.
Yeah.
Yeah, I suppose.
Yeah, well, it'd be it's Newton's third law, isn't it? Basically.
Yeah.
Yeah.
It's like,
Am I wrong? I mean, that's how it is.
the baby would be pushed backwards, wouldn't it?
Yeah, exactly.
Yeah.
Oh.
Yeah. So we should laugh.
Anyway.
Funny. Okay, right. Well, anyway, so any final thoughts? I mean, does anybody here seriously think that Elon's going to make this happen within the next 10 years, let alone the next 2 or 3?
No.
I think we'll see a Starship go to Mars, whether or not it'll be manned or not. I will say that we will have that, maybe 1 or 2 in 10 years. But at the moment, we're struggling to get to the moon. So
yeah,
I'll just say I think he's very enthusiastic.
I'll give him that.
At the same time, the company is doing a lot for space flight. You know,
yeah, absolutely.
The number of launches I've had recently with Falcon 9 and what's happening with the Starship is just incredible.
It is incredible.
Yeah.
No, I'm not trying to take away, Elon's genius and his.
But Elon isn't a genius. The people around him are geniuses. He's not.
Yeah, but he's the guy who comes up with the ideas.
Well, we can all come up with ideas. We can all do that.
Yeah.
I'd also like to repeat what Sandra's just said.
What's that?
With very lot this on Mars would be nice.
Yeah, we don't like that, Sandra. But I think that's one good thing. But I think there will be lots of downsides.
Yeah.
However, I do agree with you. It would be nice. Okay, so panel, stick your necks out. In what year roughly do you think the first Martian base as a permanent outpost will be established, even if it has to be?
I say probably within 100 years.
You don't think sooner than that?
I think for a permanent base, I think sooner than that.
No, because I go to a lot of meetings with people who are doing this. They don't see Elon Musk or anybody doing it within 100 years.
Right.
Really? Okay.
Well, I will say 2050s then.
Yeah, I was going to say 2050s. I reckon it's doable by the 2050s, definitely.
I mean, the other thing is, why the hell would you want to go and live on bloody Mars?
Yeah.
Well, this is it. What I said. The idea, 1 million people want to go and live there.
It's going to be the first station there is going to be like the Halley station in Antarctica, isn't it?
Mm.
That sort of thing.
That sort of thing.
Science.
Yeah. And Derek says maybe he wants to fill the Martian sky with more Starlings.
Well, that's
I'm sure he'll do that.
I'm sure he'll do that. It makes sense to do it for communication. Yeah. It really does.
Yeah.
So anyway, let's hear from you viewers. When do you think the first permanent Martian base will be established, even if it has to be resupplied from Earth? I mean, we're not talking a self-sufficient base because that is a long way in the future.
Oh, definitely.
No. But the first base that is permanent, that is permanently crewed. Anybody out there? Any of our viewers want to suggest a year? Just out of curiosity, what do you think, Daz?
To be quite honest, I think there'll be something there in 1950. Whether it's 1950? Come on, Bennett. We've been there 100 years. What are you on about?
Time travel.
It's about 2050. But whether or not it's a permanent base, I really can't. But then again,
right, Derek says 2150.
Yeah,
I'm more with that.
I think it will be a semi-permanent base, but with rotating crews like they do on the ISS.
Yeah. Yeah. That makes sense.
Yeah.
Anybody else out there got any suggestions? Sandra, very optimistic. Sandra, 20 years.
20 years.
Yeah.
Ooh.
So well, we hope you're right, Sandra. But
the thing is, sorry.
These things always tend to happen a lot sooner than... Can I continue?
Carry on, Andy.
Thank you.
Carry on, Andy. Don't be a bitch.
These things always happen a lot sooner than you think. I mean, for goodness sake, let's remember the Wright brothers, 1903, and 121 years later, we saw the capture of a descending booster. Yeah. That progress is amazing. So I think these things tend to happen sooner than you think they're going to. On the other hand, we do know that we've got a lot of problems to solve. So anyway, so any other suggestions? I mean, Keith quite rightly says it used to take 6 months to get to Australia. And of course, if we do, I mean, NASA are working on nuclear electric propulsion, which will cut down the flight time to Mars to maybe 3 or 4 months, quite a substantial reduction. So that makes resupplying a base even easier, and make the whole thing really easy. So there are all sorts of things to take into account here. So anyway, thank you for the discussion, everybody. I'm sure this is a subject we'll return to in the future. So I'm going to call upon Daz now to tell us what's going on with the sun.
The sun, man. Right. Okay, then. Basically, I've got to cover 2 weeks. I'm not going to bore you to tears for an hour and a half, although I could do if I was being really mean. But what the first thing I've got to do? Well, first of all, let me get my thing up. Let's have a look. Over here. Oh, I've disappeared. Where have I gone? There we are. Right. Can everybody see that?
Yeah.
Yeah.
Can you see my cursor?
Yeah.
All right. I've got to just move over to right. Right, here we go. So you can still see my cursor, yeah? Yeah, okay then. Right. What first thing I've got to tell you, and it's probably old news to a lot of you, is that basically welcome to the solar maximum. On the 15th, a statement was put out by who was it? NASA, the National Ocean and Atmospheric Administration, NOAA, and the International Solar Cycle Prediction Panel that we are officially now, or have been, because I've got to emphasize it, we are officially now in solar maximum. Now I've got to reiterate, solar maximum is not a point in time. Solar maximum is a phase transition from basically the solar cycle sunspot numbers increasing to reach a maximum and then to decline again. So when we look at the solar maximum, we are looking at a phase time. It's not just one point. We won't know that for at least 2 or 3 years at least. According to the panel, we've been in solar maximum for 18 months already. So we're talking about going back into 2023. So they say we've been in there already 18 months, and they reckon it to last at least until towards the end of 2025, if not go into 2026. So and even then, that's not decided upon. They don't know how long the actual maximum is going to be going. So we've had 18 months already, and we could have another 18 months to come. So it could cover 3 years. And it won't be until we see the sunspot numbers decline for a period of time of up to at least 6 months, if not to a year, that they can actually say that the maximum will have actually finished. So if you can look here, remember our little map that we get off of NOAA. You can see we had a big peak. What were we in there? We're in October. In so we had a big peak. We had a big drop in September. So in the month before, we had the big peak at the top. So we had a drop from the peak in September. October, I will tell you now, I expect that to rise again. Possibly nowhere near as high as what it is now, but I expect it to go up again. And remember, if you remember, I've said before, we get this sort of like you end up with the shape of like a slice through a volcano. You'll get 2 peaks. Sometimes you even get 3 peaks. But we will have a sort of like a profile of a volcano in the end, because you'll get 1 peak, it'll dip down, then it'll possibly peak again, and then we may get the decline, or we may even peak again. So so what you've got to look at it is not a point in time. We won't know the exact point of the solar maximum when it totally changed until probably 2 or 3 years time. So we are so we're in this phase now. Now we are, as we all know, we've had lovely auroras over the last, well, the beginning of this year, over this year. And what I will do is I will just move this one on. Now you remember the Bartel music sheets, diagrams that they talk about. This is for the year so far. So as you can see, now remember at the top where it's got the numbers right at the top, that is the day number of the rotation interval. It takes the sun 27 days to rotate. If you want to see the dates of the actual days and all that, you have to look underneath each line as it comes along. So if you look at the January the 1st, that actually started on solar rotation day 24. But what this is showing your KP indexes for every day. In fact, it's every 3 hours. So as you can see, if you look in where are we? In March the 10th, we had May the 10th. Sorry, you can see we've got that big solid block, and that was the big auroras we had at the time, and that was the ones we saw in the gallery. And that's when we had the most glorious auroras. For as you can see, it covered two and a half days. So and we've had other events since then. I'm just going to go to I can't see me. There it is. There you go. And this is 2003. As I said, we've been in they said the solar maximum, and basically we've always gone back to 2 years really, because we had in with February, March, and April. You can see we had some events happening there, but they haven't been to the extent that we had them this year. So they're saying we are in the maximum. So we've had auroral action increasing during the max, but and the sun action still remains high. But the sun's action will still remain high even as we go into the decline, and this is what causes confusion. In fact, on lots of cycles, the decline of the sunspots, because you're moving towards, remember, the sun's magnetic poles are going to swap. That you're basically heading to quite a traumatic time, I presume, because it's going to mess the sun up for a little while. So they said you tend to get more action on the decline. So we get it through the maximum and in the decline. So again, this is why they need to see this going on for at least 6 months, if not a year, of decline in sunspot numbers. But it doesn't mean we're not going to see any action. In fact, they're predicting possibly the next 18 months we're going to see in heightened auroras, CMEs, flares over the next 18 months. So we're going to see more of it. So welcome to Solar Max. Just thought I had to put that in there. A lot of you probably already knew that. I've lost my cursor again, keeps disappearing. So there you go. Welcome to the Solar Max. Now let's get on with what we had over the last couple of weeks. Now, the end of last week, it was. Let me get this right. I've lost it. Where's he gone? Last week we had 38. I think it was 3852. Leave the side of 3854. As it went over to the just going off the west side, we actually had it fire off 4 flares within less than 12 hours. So this was the first one. As you can see, this was it on the 18th at 5:30, basically in the evening. So we'll go to the next one. The next one was just 7:30. The next one was 11:30, and then the final one just before it disappeared off the actual side of the western limb was at 7:01 in the morning. So he was determined that he wasn't going to go into that dark night without kicking up a bit of a fuss. So that was an event that happened just last week on the 18th. So this was the sun today. we have 12 regions, numbered regions on the sun's face at the moment. As you can see, most of them are confined to the southern hemisphere. If you remember 2 weeks ago, I hope you can see my thing. This area here was the big splodge I was talking about. So this is the some of these are old regions that have come back in, and they've already started to provide us with quite a bit of action actually over the last week. So we'll just move on. This is the synoptic diagram for today. This shows you everything where it was it was 3 in the morning, nearly 3:30 in the morning, wherever it was done. Probably it's in the USA. We've got 3, you can see 3 dark areas. They're coronal holes. They're not in any sort of position to really give us much in the way of solar wind. Possibly number 86 possibly will do in a few days' time. You can see the neutral lines separating the negative and the positive areas. These are the filaments that sit along these lines. Now, if you remember, if you look up the top here, the whole disk forecast, they're predicting that we're going to have 99% chance of C flares. They're just called common flares. That's why the name's C. Then you've got 75 medium flares, percent chance of medium flares, 30% of X flares, and a proton storm. They're saying you've got a 99% chance of it actually us having a big storm. Okay, fair enough. And as you see, all these numbers also sit underneath all the numbered regions, and they mean exactly the same thing. 3872, they're expecting C class 80%, 35% M, and 5% X class flares. And if you look under each one, they've all got these these numbers, and they're sort of like hedging their bets on what possibly could happen with these over the next 24 hours. So move on again. This is last week. I've only done the blue sun this week because there seemed to be a problem with the other with heliosphere. It kept stopping, starting. It wasn't the machine. It was actually on their part. That was the first X flare we had this week, which was a 3.3 flare. In a short while, this is the big blob that we were talking about coming in. So that's all those regions just starting to come over the eastern horizon. And that was the second X class flare. Now that was only a 1.8. But if you go back and have a look at that again, it was a bang bang. Just before, about an hour before, there was an M class flare, which got masked by the X class flare that happened a little while after. And the M class flare was M9 point something or other. So it was almost 2 X class flares within an hour. Now they did. I'll just run that again for you. So look out for these X class flares. There is a little bit of action going on the western side, but you can see all this stuff coming around on the eastern limb. This is what we've been expecting. Very shortly, we'll get the first flare, which is the big one. That was a 3.3, but most of that was directed away from us. We did get a side swipe, and there's probably a G1 storm associated with, which means any aurora would be up in the Arctic circles. And there was the 1.8. But as you saw, it was a bang bang because 2 of them went off together. So that's basically what we've had today. And of course, I did see people start trying to predict that there would be auroras seen all over the UK. But I didn't put out a warning because I wasn't convinced, because there's been very little action to go along and enhance these flares. So we did have some N-class flares, we did have some C-class flares, but nothing to really clear the way or to buffer for the X-class flares to buffer up to and create a big flare. So yes, we did have auroras, but they were restricted to the Arctic circles. So that's that one. Now what we got here? Now this one here is the 3.3 flare. You just saw it fire off just there. And this is in 4 different wavelengths. So this is the 3.3 flare. No, I apologize. This is the 1.8 flare. You can see it slightly lift off in these things. So it lifts off there. But what it did produce is a full halo, which you'll see in a second. If you watch this, you will see that it actually did produce a full halo. You can even see in this chronograph. You can see there is a full halo there. So we knew we were going to get something from that. But again, it was just going to be a side swipe. So that's it. So here is that again. Let me just start this. Hopefully it will work. These have got a bit temperamental. So you saw that there. Dave will do it again for me because they never do. There it goes. So what I'll do is I'll just there you go. That is the actual extent of it. You can see most of it's heading towards the east and to the south, but you can see a faint halo all the way round. So we knew we were going to get a side swipe from this, if nothing else. So let's move on. Boom! Don't want to see it again. Just determined that's just the still picture. And as you can see, if I just use my cursor, you can see the shock wave all the way around here, and this is what I mean. And it comes all the way around, and it was a full 360 halo. So that's what I mean by a halo. So it's the actual shock wave, so we know it's coming our way. So that's what we saw. Now this is the regions we've got on the sun today. As you said, there's 12 of them, and as you can see, we've got 3 regions: 3874, 3872, and 3869. Now these have, as you can see, they're in marked red, and they've got 3 letters in them. These have the most magnetic complexity within inside them, and these are the ones. These are the bad boys that are possibly going to give us some more action over the next few days. And remember, most of these now are sitting basically in the center of the sun. So if they do fire off anything in the next couple of days, we're going to get something, and hopefully we may get some action from it. So that's just showing you what's the complexity of all the sunspots are. The active regions are. So here's now this is from the 28th, so this is 24 hours old already. This is what's coming around the mountain. So remember, what you see in grey is what's on the Earth side. This is what we're seeing when we look at the sun at the moment. This is the western side, which is where everything's disappearing off. This is the eastern limb, and as you can see, we've got this big black splodge. It's probably already moved onto the fully onto the face of the sun. So it's looking at us right now, and that is quite a big active region. So again, that could give us some fun in games. And there are, as you can see, there's another lot sort of like halfway down back on the western side, and they were 385 and 3852. 3854 and 3852, and they gave us quite a lot of action last time, and they've seemed to have merged. So again, watch out for this. We're going to have stuff over the next week which is going to give us some interest. So let's move on. This is the last slide I'm going to show you. This happened earlier today. It was a lovely eruption, a lovely CME on the southwestern limb, which fired off today, and it was almost 1:45 this afternoon, UTC. So that again, that will be firing off. Most of that will be going to the east, the southeast, but again, we may get something from it. Hasn't been modelled yet. I haven't seen anything from it, but I saw that a bit late, so I thought I'll put it up there just to show you a beautiful prominence and eruption from the sun today. So there you go. I hope that fills you in for the last 2 weeks.
Mm-hmm. Here we are. Excellent.
Right.
Well, thank you very much for that, Daz.
That's
So,
right.
well, we don't know what's in store exactly. So there's a lot of stuff on the back side of the sun that people have been talking about recently.
Yeah.
So we'll see what
There-
happens.
There's a lot of stuff going on.
Lot of stuff.
There's a lot of research going on. Our GOES, was it GOES 16 we covered the launch of? Was it 16?
Yeah.
It on there it's got a special coronagraph, which because it's gone out to Lagrange point 1, if I remember right. And no, sorry, it hasn't. No, it hasn't. It's doing around the Earth, isn't it? The GOES satellites.
Yeah.
But it's this coronagraph will give us images in half an hour.
Wow.
Remember, we're talking about we need to develop warning systems for these things. So this coronagraph will give us images within half an hour. At the moment, it stands at 8 hours. We have to wait
That's
8
brilliant.
hours for it to be processed, analyzed, and then put up. So
Superb.
this will give us a lot earlier warnings. There's other satellites out there that are going to be launched soon, which are going to give us far. There is one to go out to. I can't remember the name of it. Out to Lagrange point 1, and that's going to have a suite of instruments that's going to give us all the data. It's ASAP. As soon as anything hits that, it's going to send it straight back to us. We're not going to have to wait. So for us to be able to develop warning systems, and as I said, they're also doing the same for Mars.
Great. All right. Thank you. Well, there we are. So I think we'll start drawing things to a close this evening. Obviously, we'd like to thank you all out there for being with us this evening. Your support is much appreciated. And if you would like to support Space Oddities, well, of course, you can do so by buying us a coffee. And if you scan the QR code, you can buy us a coffee. And all the money that we receive from good people like yourselves goes towards keeping the channel going, and is much appreciated. Again, apologies for the link to that not appearing in the chat. I am trying to get it resolved. It's under investigation, but it's been under investigation for a long time. It's typical that it would have to be us that has a problem that they're really scratching their heads over, but that's the way it goes. So you can buy us a coffee. You can click the super chat icon underneath the chat window, the one with the dollar symbol on it, and that will allow you to make a donation directly to us. And there we are. And we do thank you so much, those of you that have donated and perhaps will continue to donate. Thank you so much. Again, if it's your first time here this evening, thank you so much for being here. We hope you'll come back next week and every week. We will be back, of course, at the same time next week with more fun stuff from the cosmos. And there we are. I'd like to thank the panel for being here this evening. Nice to see you back, Ian. Hope you can come back next week. You're more than welcome. So you can join us. And thanks to Roger, as ever, for his Sky Guide. And
thank you.
Henry, thanks to Pete for being here and sharing things with us, and sending us some wonderful images. And I see that Gerard has been already active this evening, already sent us in a few emails for next week with some images. So that's great. So thank you very much for that. And for yours. All right then. Have a fantastic week, everybody. From all of us at Space Oddities, be good, look after each other, and we'll see you next week.
Keep looking up.
Yeah, keep looking up.